Hi and welcome back to Vista Academy SALEM and ERODE. We are into the topic of trigonometry, which is very most important for our SSC and RRB preparations for all different types of competitive exams comes under advanced mathematics. In our previous sessions, we have already discussed about the trigonometric ratios and also the values or the table that we are going to use frequently for trigonometric ratios, right? So we know the values of sine 30 degrees, 0 degrees, 60 degrees, 45 degrees, 90 degrees, which are very most important. And if we know the values of sine theta, then usually we can do all the values of other trigonometric ratios also. In this session, we are going to fetch our studies more deeper into the angles and also its measurements of trigonometric ratios. As we know, angles are and its measurements is nothing but to learn about the quadrants in which our trigonometric ratios are going to be lying on. Let us check out. Now I am taking one coordinate plane. Everything we are going to calculate by based upon the coordinate plane only. As we know that coordinate plane is nothing but which is having x-axis and also y-axis. The same coordinate plane I am going to take here x-axis and also y-axis. These both act as a positive. And x imaginary is our x dash and y imaginary is our y dash. Now let us check out how easily we can remember the trigonometric ratios quadrants and based upon how the values of this one positive or negative where it is going to be lie. Let us check out from this particular video. Now every time the thing which we need to remember is that theta always starts from anti-clockwise direction, not in the clockwise direction. If it is anti-clockwise direction, then if the point is here, then the theta we are going to calculate in the anti-clockwise direction from x-axis to the y-axis first. If it is 0 degree, now the rotation that theta is taking is anti-clockwise direction and it reaches to 90 degrees. Because exactly the y-axis will be perpendicular to the x-axis, so the value which is lying on the y-axis will be equal to your 90 degrees. Again from 90 degrees it takes the anti-clockwise direction and it reaches to the origin of 180 degrees. And then from that you are going to take the another rotation of anti-clockwise direction to the negative y-axis, then the value will be equal to, the angle of rotation will be equal to from 0 point to here it is 270 degrees. And from here to here it is again reaches to its origin and this is only nothing but called as your complete rotation which is equal to 360 degrees, right? So from here you are going to start the anti-clockwise direction and every part of your quadrant is taking 90 degrees of anti-clockwise rotation. That one we have to remember, right? Now the quadrant which is present in the positive of x and y axis is nothing but called as our quadrant 1. This is called as our quadrant 1 and the next to it is called as quadrant 2 and the next it is called as quadrant 3 and the last one is called as quadrant 4. Quadrant 4, right? So here how we need to remember is, here the theta is lying in between 0 degree and 90 degrees. The theta which is lying from the 0 degree to 90 degrees is our quadrant 1 and this can be written as 90 minus theta. Means all the values less than 90 will be present in quadrant 1. And then coming to the second quadrant, theta is lying in between after 90, from the 90. This is also line which is taking part in this particular quadrant. So theta will be lying from 90 degrees to 180 degrees. So this can be written as what? 90 degrees less than or equal to theta less than or equal to 180 degrees. Here we are going to write it as 90 minus theta is completed, then here it will be 90 plus theta and this also can be written as 180 minus theta. This is the angle identification when we are going to use. Next, coming to the quadrant 3, here the theta is lying in between 180 degrees and the 270 degrees. So it is 180 degrees and 270 degrees quadrant, or else you can write it as 180 degree plus theta, or else this can be read as 270 degrees minus theta also. Next, coming to the fourth quadrant, theta here is lying in between 270 degree to 360 degrees. Therefore, theta can be written as, or else it can be written as 270 plus theta, 270 degree plus theta, or else this can be written as 360 degrees minus theta. When it is completed its whole rotation of 360 degrees, again the rotation will be changed to our first quadrant. That is nothing but, already we have written here 90 degrees minus theta, then this will come to 360 degrees, already minus theta is completed, again it will take into the second rotation and it can be written and read as 360 degrees plus theta also. So quadrant 1, quadrant 2, quadrant 3, quadrant 4, the theta values are going to be like this. Now let us check out how we are going to remember easily and one logical manner to remember which trigonometric ratios are positive in which quadrant. Now, the universal code for remembering our quadrants of trigonometric ratios is all silver tea cups. This is a universal identification that we are going to remember for quadrants. Here, first letter of each and every word will decide which trigonometric values will be positive in your quadrants. Here all is nothing but what? All the 6 ratios, sin theta, cos value, tan value, and inverse of this one means cosecant theta and secant theta and cot theta. All the values will be positive values. Here we are going to take all the values are positive values. Now coming to the second quadrant, the first letter is sin, S. S is nothing but we are going to take it as sin theta, and also inverse of the sin theta is cosecant theta. These two values will be positive values and rest of them all are negative values. Means cos theta, secant theta, tan theta, cot theta values will be negative in quadrant 2. Next, coming to the third quadrant, that is T. Tan theta and the inverse of tan theta is cot theta. These two values will be positive values and rest of them all the values are negative values in quadrant. Means sin theta, cosecant theta, cos theta and secant theta are negative. Only the tan theta and cot theta are positive. Coming to the fourth and last one, that is, it is starting with the cups. Means C. C is nothing but represents cos theta and the inverse of cos theta is secant theta. These two values will be positive values in our fourth quadrant and rest of them all means nothing but sin theta, cosecant theta, tan theta, cot theta. All the values are negative values in this particular quadrant. So this is the quadrant identification of our trigonometric ratios where we are going to see the theta values and we are going to calculate the values in which quadrant it is going to be lying. First quadrant, second quadrant, third quadrant, fourth quadrant. Here all the values in quadrant 1 will be taken as positive value. All the values, only sin theta and cosecant theta are taken in the positive value and rest of them are negative values. Tan theta and cot theta are taken in the positive values and rest of them are taken in the negative. And next cos theta and secant theta are taken as the positive values and rest of all the other values are taken as negative values. By using this one we can solve many of the problems. Hope so you have understood very well. And next, coming to the next set of formulas where it is very much useful entire mathematics, not only in the trigonometric but also it will be useful for your physical studies and also to solve many other things. That is only nothing but called as trigonometric identities. Very important trigonometric identities, or else this is only called as Pythagoras identities. Pythagoras identities, or else the other name is square laws or square identities, because all the values here we are going to consider it as square values. Let us check out the 3 most important formulas that we are going to see in the trigonometric identities is, first formula, sin square theta plus cos square theta is equal to 1. The foremost and the first identities formula is sin square theta plus cos square theta is equal to 1. And next, from this I can derive my sin square theta is equal to, here positive cos square theta is there. If it goes to right hand side, then it will become 1 minus cos square theta. Then I can write my sine theta is equal to square. If it goes to the right hand side, then it will become as under root 1 minus cos square theta. Right? So this is the formula where you can derive sine square theta and then sine theta. Now coming to the same set of formula, I am going to derive my cos theta. How? Let us check out. Here cos square theta, you just take cos square theta. I am taking the another formula for derivation. Cos square theta is equal to, if sine theta goes to right hand side, then you can take it as 1 minus sine square theta. Therefore, from here cos theta will be square. If it goes to right hand side, you are going to write it as 1 minus sine square theta. In trigonometry, we are going to see all the problems where we need to substitute all the values of sine theta, cos theta wherever it is required. So, based upon one single formula, that is sine square theta plus cos square theta, we can find out the values and substitute the values instead of sine square theta as 1 minus cos square theta, sine theta as under root of 1 minus cos square theta. And in the same manner, you can substitute the values for cos square theta and also cos theta. The second identity formula is secant square theta minus tan square theta is equal to 1. Here it is a plus, here it is a minus. Just we need to check out that one. Now from this, I can bring out secant square theta is equal to, if this minus value goes to right hand side, then it will become 1 plus of tan square theta. Then what is my secant theta is equal to, under root of 1 plus tan square theta is my formula for secant theta. In the same manner, if I want to take out what is tan square theta, here tan square theta, it is in the negative form. Just bring it to right side and bring this one to the left hand side. Then you are going to see tan square theta is equal to secant square theta minus 1. This will become as minus 1 because I am multiplying with minus on the both sides, or else bring this minus term into the right hand side, then it will become as a positive term. Therefore, tan theta will be equal to under root of secant square theta minus 1, I can write. Right? Next, coming to the third identity. This is the second one and this is the first one where we are going to use all different types of trigonometric problems. Here cosecant square theta minus cot square theta is equal to 1. The last identity is cosecant square theta minus cot square theta is equal to 1. Then what do you mean by cosecant square theta here? Can be written as negative value. If it goes to right hand side, then it will become 1 plus cot square theta. Therefore, cosecant square or cosecant theta will be equal to under root of 1 plus cot square theta. Next, from here I can derive what is the value of cot square theta. Just derive the cot square theta. Cot square theta is equal to, negative value is there. If I bring to the right hand side, then it will become positive. Then the value of 1 will come to the left hand side. Then it is cosecant square theta minus 1. Therefore, cot theta can be written as under root of cosecant square theta minus 1. So these are the different formulas where we are going to use 3 different identities formulas, and we can derive all the values when they are going to be substituted in the formulas, right? Let us check out one question and one simple problem based upon these identities. Problem, let us solve one problem based upon the square identities. If secant square theta plus tan square theta is equal to 7, then find the value of theta. Now they are asking us to find out what is the value of theta. Already they have given one condition. Here all the problems in our trigonometry will be based upon the conditional problems. If you are saying the value, if you are saying the word if in your trigonometric ratios problem, then something they are going to compare with some other thing. If secant square theta plus tan square theta is equal to 7, then find the value of theta they are asking. Means if conditional state this one, we need to prove by using this particular condition. What is that condition? Let us solve the answer. Secant square theta plus tan square theta is equal to 7. We given that. Okay. Now, can I substitute my secant square theta value or as tan square theta value? As we know that secant square theta minus tan square theta is equal to 1. Just now we have learned secant square theta minus tan square theta is equal to 1. Therefore, from this I can substitute secant square theta is equal to, if it goes that side, 1 plus tan square theta. Now, I am just substituting my value of secant square theta in this particular formula. Just check out secant square theta, I can write it as 1 plus tan square theta plus already tan square theta is there, then tan square theta is equal to 7. In the next step, tan square theta which is equal to 2 tan square theta. 1 plus 2 into tan square theta is equal to 7. Bring this 1 to right hand side. 2 tan square theta is equal to 7 minus 1 is 6. Then tan square theta is equal to 6 by 2 which is equal to 3. Now they are asking us to find out what is the value of theta. Then tan theta will be equal to square, if it goes to right hand side will be equal to 3. Now just to substitute the value where theta is equal to tan inverse of root 3, where our value of tan will be equal to root 3. The value of root 3 in our tan table will be equal to theta is equal to tan inverse of tan 60 degrees. If it is tan 60 degrees, then the value of tan 60 will be equal to root 3. Then inverse of root 3 and tan, inverse of tan and tan get cancelled. Therefore, my value of theta will be equal to 60 degrees. So these are the simple problems that we are going to use by using this particular trigonometric identities formulas, and we are going to derive different types of problems. And for more updates, stay tuned with our channel Vista Academy SALEM and ERODE. Thank you so much. Stay tuned.